This video is a follow-up to our previous video on how to measure IP3. It describes how the IP3 measurement process can be automated. In our previous video, we talked about what the third order intercept point is and how to measure it for an amplifier. In practice, you may have lots of measurements to take, maybe at different power levels or different tone spacings, in which case the setup that we showed may be too time consuming and you may want to automate the approach. There are a couple of different ways to do this. The one that we adopt here at PRFI is to design our own test system, which we program in Python, that you can use other languages. An alternative would be to make use of third-party software, potentially from test equipment manufacturers like Keysight and Rohde & Schwarz, which may be faster to set up, but not quite as customizable. The measurement setup for measuring IP3 here is mostly the same as in our previous video, the same signal generators and spectrum analyzer. We use the two signal generators to set the level of the input tones. These are combined using an RF combiner that provides isolation between the two generators. The output from the DUT goes into a spectrum analyzer, where the output spectrum can be observed, the tone levels measured, and the IP3 determined. The main difference is the laptop that we've added, which controls the program and communicates with the instruments and the required cables. Again, we're measuring the CMX90B702 from CML surf range. Before we start the main measurement routine, there are a few things that we need to do. We need to measure the loss of the components between the DUT and the spectrum analyzer, and we need to determine what powers to set the signal generators to, so that the output tones have the same magnitude at the spectrum analyzer. It's also a good idea to take a few manual measurements before starting the automated routine to make sure there are no problems with any of the test equipment and the setup, or with your measurement program itself. The main two-tone program is now running. The two fundamental tones on the spectrum analyzer are increasing in 1 dB steps, and the intermodulation tones are increasing in larger 3 dB steps, as expected. A small delay has been added between measurements to make it clearer for this video. A graph of output IP3 is plotted against output power per tone as measurements are taken, which lets us view the measurements in real time and helps to quickly identify possible errors in the device or in the program setup. If you're measuring devices over a wide power range, the intermodulation terms may start below the noise floor, so the IP3 measurement appears to improve with increasing power, even though this is not actually the case. For this setup, the intermodulation tones appear above the noise floor around -12 dBm output power per tone, so after this point we're actually measuring IP3. There is then some variation in the measured IP3 with tone level, which is normal. Reducing the resolution bandwidth will lower the noise floor, so IP3 can be measured at lower output powers, but the program will take longer to run as a result.